example H. First, we're asked to take the partial derivative about the x variable. Since it only shows up once in the numerator, as we've already seen, we can let that variable go to 1 and leave the denominator as is. So our partial derivative is just 1 over y. Now, to find the partial derivative of y, let's rewrite the question. So instead of seeing as it x divided by y, we're going to look at it as x times y to the negative 1. Now, we just saw some problems where the variable we were taking the derivative of was in the denominator, but because it was part of a binomial, we use the quotient rule. But here, we could just rewrite the question. So then when we take the derivative, we treat the x as a coefficient, and we only focus on y to the negative 1, which has a derivative of negative y to the negative 2. And so we just have our x and, well, our invisible negative 1 in the numerator, so that we have negative x over y squared when we fix our negative exponent. Or, you know what, just use the quotient rule. If you saw this as a quotient rule problem, you're still going to get the same answer. So when we take the partial derivative about the y variable, we start off by treating the numerator x as f, and we take the derivative of that about the y variable, but we get 0 since there is no y, times g, which is our denominator, which in our case is a y, minus then f, the original numerator of x, times the derivative of the denominator, but we're taking the derivative about y, so it's just a 1, all over the denominator squared, which really is just 0 minus x over y squared, or negative x over y squared, the exact same answer. And then to finish this off, we're asked to find, I stopped highlighting up here, k sub z, the partial derivative about the z variable. But wait, there is no z value, so the derivative is just 0. Now, the reason you might see a function like this, where you're expecting z to be the input, but you don't have it, is perhaps you own a store in California and in Oregon, and in California, you have to pay state tax, but in Oregon, you don't. So if x represented state tax, you always want to think about it in terms of your function, but it's irrelevant for your Oregon store because you're not paying state tax. Really, as a customer, there's some behind-the-scenes stuff, but the point is there.